Let us see some additional problems on permutations. First question, how many permutations of the letters A, B, C, D, E, F, G, H contain the string A, B, C as a consecutive substring? So here the letters are A, B, C, D, E, F, G, H and they should contain A, B, C as a substring. So here this is the same as the number of permutations of the following 6 objects. That is 6 objects are A, B, C, then D, comma E, comma F, comma G, comma H. So the answer will be 6 factorial, which is 720 ways. That is, this ABC could be either here or here or here, here. So considering this ABC as one single bundle, so we can do it in these many ways, that is 6 factorial ways. Second question, how many different strings can be made by reordering the letters of the word success? So in this case you have to find total number of letters, that is 1, 2, 3, 4, 5, 6, 7. So the numerator will be 7 factorial divided by, so S occurs 3 times, so 3 factorial, and C occurs 2 times, and U occurs 1 time, so 1 factorial, and E occurs 1 time, so 1 factorial we have left, and the remaining will be 2 factorial and 3 factorial at the denominator with 7 factorial at the numerator, which is 420. So third question, how many pairs of dance partners can be selected from a group of 12 women and 20 men? So here it is permutation of 20, 12. So you have to select 12. How many pairs of dance partners can be selected? So here the answer is, it is just a minute. Here it is not in permutation, actually it should be in a product rule, because first either a man or woman can be selected and then one man and one woman from each group. So it is 12 into 20, that is 240 ways. Here it is a product rule, not the permutation. Next, find the number of permutations of the letter word climate. First one is with no restrictions. So when it is no restriction, it is since all the alphabets are distinct, so it can be done in 7 factorial. Next is vowels occur in odd places. So there are totally 7 positions, 1, 2, 3, 4, 5, 6, 7, and it is given that vowels must occur in odd places. So odd places you have 1, 3, 5 and 6. So these 3 vowels A, E and I, and there are 4 odd positions, 1, 3, 5, 7. So these vowels can be arranged in 4p3, which is 24 ways. So first position, second position, fifth and seventh out of these 4 positions. So these vowels, which are 3 vowels, can be placed in any of these 3 positions in 24 ways. And the remaining 4 consonants, that is CLMT, they can be arranged in 4p4 ways, which is 24 ways. So therefore the required answer will be the product of arranging the vowels multiplied by arranging the consonant, which is 576 ways. Next question, in how many ways the letters of mathematics be arranged? First one is with no restriction. Whenever it is no restriction, count the total number of alphabets divided by above will be the total number of alphabets factorial divided by each character how many times it appears. So here the answer will be 11 factorial, that is totally there are 11 alphabets, and M occurs 2 times, so 2 factorial, and T occurs 2 times, that is 2 factorial, and A occurs 2 times, 2 factorial, and the remaining are single time, so it is 1 factorial. So it is 2A, 2 times A, 2 times M, and 2 times T, that is 11 factorial divided by 2 factorial divided by 2 factorial, 2 factorial. Next is all vowels come together. So here you should first identify which are the vowels, A, E, A, and the remaining are the non-vowels. So what we do here is A, E, we make it as one group. And now we have to arrange the totally there were 11, and then out of that we have 4 vowels. So it is 7 plus 1 group, that is 8 letters, and out of which M occurs twice. From the first group M occurs twice and T occurs twice. So therefore the number of ways arranging these letters will be 8 factorial divided by 2 factorial into 2 factorial, which is 10080. Now, these AE has 4 letters in which A occurs 2 times and the rest are different. So, the number of ways of arranging these letters among themselves, AE, is 4 factorial divided by 2 factorial, which is 12. Therefore, the totally is arranging the 8 letters followed by these arranging these AI, which is 12, which is totally will be 120960. Next question. The number of permutations of the letters in the computer will be 8 factorial. Next, how many 5-letter words are possible from the computer? So, there are totally 8 alphabets and all are different. Therefore, it is 8p5. You have to arrange only 5 characters from this, so it can be done in 8p5. Why it is permutation here is it is arrangement, not the selection. So your permutation is the arrangement, whereas combination is the selection. Next, in how many ways can the English letters be arranged so that there are exactly 10 letters between A and Z? So here the number of ways of arranging 10 letters between A and Z is that is 24p10. Since we can choose either A or Z to come first, then it will be 2 times 24p10 arrangements of this 12-letter block. Then for the remaining 14 letters, there are 14 factorial arrangements. Therefore, in all, there are 2 into 24p10 multiplied by 14 factorial ways. Next question. How many permutations of the letters A, B, C, D, E, F, G contain either the pattern BGE neither the pattern BGE nor EAF? So here you find the total permutation, that is 7 factorial, and we fix the pattern BGE and then we can consider it as a single block, and that, as we have seen previously, the same we will do, and thus the number of permutations with this pattern will be 5p5, which is 5 factorial. That is because here BGE and the remaining will form 5, BGE as one group and the remaining letters will make 5 groups, so it is 5 factorial, and all are different, so it is nothing divided by 1 factorial. Then fixing the pattern EAF, we have the same number, that is 5 factorial. So thus we have 7 factorial minus 2 into 5 factorial. So but here there are some overlapping. So we have taken too many permutation, ones containing both EAF and BGE. So here there are two cases, when EAF comes first or when BGE comes first. So EAF cannot come before BGE, so this is not a problem. So if BGE comes first, it must be the case that we have BGEAF as a single block, and so we have 3 blocks or 3 factorial arrangements. So therefore altogether we have 7 factorial minus 2 into 5 factorial plus 3 factorial, which is 4806 different ways. Next is how many paths are possible from 1, 2 to 6, 9, considering one right or one up move. So that is nothing but you have you are right now in the coordinate system, that is first quadrant, from at the location 1, 2, and you have to reach 6, 9. So considering each move as one right move or up move, so how many paths are possible? So here there are 6 minus 1 right moves, that is 5 right moves, and 9 minus 2, 7 moves which are up moves. And so it is like arranging 5 R's and 7 U's. So it is nothing but you have RRR 5 R digits and 7 U's. So which can be arranged in 12 factorial, that is 7 plus 5, totally there are 12 digits to be arranged, that is 12 factorial, among which 5 are R and 5 are 7, which are similar. So that is divided by 5 factorial into 7 factorial ways. Next is combinations. In a sequence of 10 coin tosses, how many ways can 3 heads or 3 heads, that is nothing but 7 tails, come up? Or the question could be either 3 heads or 7 tails. The answer will be the same. So here the answer is the number of ways of choosing 3 heads out of 10 coin tosses is 10C3, that is nothing but 10 factorial divided by 3 factorial into 7 factorial, which is 120 ways. Next, how many possible committees of 5 people can be chosen from 20 men and 12 women if first is exactly 3 men must be on each committee. Second one is if at least 4 women must be on each committee. So for the first one, we must choose 3 men from 20, then 2 women from 12. So this is nothing there, and these are not mutually exclusive. Thus, by the product rule, these are mutually exclusive. Thus, there are 20C3 into 12C2, which is 75240. Next, for the similar way here, at least 4 women. So at least 4 women matlab, so 12C4 multiplied by 20C1, or all 5 could be women, so it is 20C5 into 12C5 into 20C0. So the sum of these two will be the final answer. Next, there are 25 juniors and 28 juniors and 25 seniors. Find the number of ways of selecting 9 from juniors and seniors. So the answer will be 50. Totally there will be 53 people. So out of which you have to select 9 juniors and seniors. So it is 53, choose 9. It is not a slash. Please correct this. So it is 53C9. Next is 2 juniors and 1 seniors are the best, and a group of 9 which includes this best juniors and seniors. So these 2 juniors and 1 senior are already selected. Then so you have to subtract these 3 from 53, so you will get 50, and you have to select only 6. Already 3 are selected, so it is 50C6. And 4 juniors and 5 seniors. So it is 28C4 multiplied by 25C5. Next question, there are 36 girls among which 4 teams of 9 girls to be formed. How many ways it could be done? So the first team of 9 could be done in 36, choose 9 ways, and the next team can be formed from the remaining 27. Have to select 9, so 27, choose 9, and the next team from the remaining 18 I have to take 9, so it is 18C9, and the remaining 9 choose 9. So it is 2.145 into 10 to the power of 19 different ways are there to do it. So we'll continue in the next video. Thank you.